my lesson. Today we will be discussing more of the theory, relations and functions. Now here is an important example. Say NC0 plus NC1 plus NC2 plus etc. NCn is 2 raised to n. We have seen this result in the binomial coefficients problems. Now if you consider NC0, this is 1. NC1 is n. So from NC2 onwards, the number will be 2 raised to n minus 1. Now from NC1 onwards, the number will be 2 raised to n minus 1. So n of a, number of elements in a equals n, means number in the power set of a is 2 raised to n. Either this is a very important idea. Now an example, we do an example. If the number of subsets of a set A with at least 2 elements is 1013, find the number of subsets with exactly 3 elements. So at least 2 elements, NC2 plus NC3 plus NC4 etc. NCn. So this part is given as 1013. So 2 raised to n minus 1 is 1013. Now we know the powers of 2. 2 raised to 5 is 32 etc. So 2 raised to 10 is 1024. So this number is near 1024. So n is 10. You can substitute and see. 1024 minus 10 minus 1 satisfies 1013. So n equals 10. Now the question is exactly 3 elements. Answer is 10C3. 10 into 9 into 8 by 1, 2, 3. It simplifies to 120. So NC0 is 1, NC1 is n, etc. All these results will come together in such questions. So make sure that you understand this formula. Now we consider an important idea. Function. A function f is a notation. F from a set capital A to B is a relation from A to B. So function is a relation. Now such that every element of A has one and only one image in B. So every element of A should come there and every element should have one and only one image. Now example, A is the set 1, 2, 3, B 4, 5. We know A cross B. We take an element of A, pair it with an element of B in all possible ways. So 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. R1, we are getting a subset of this. Relation is a subset. So 1, 4, 2, 4, 3, 4. Now we see, in this case R1, first components 1, 2, 3. 1, 2, 3 is A. So this is a function. And every element of A has come there. Also, 1 does not go to different places. Only one image. 2, only one image. 3, only one image. 1 and only one image is a function. Domain is A. We see domain of F is a must. This is a condition, must. And range can be a subset of. So range of F is the set 4. Now R2, 1, 4, 1, 5, 3, 5. This is not a function as 1 goes to 4 as well as 1 goes to 5. One and only one image. That condition is not satisfied. Image of 1 is 4, then image of 1 is again 5. So this contradicts the definition of a function. R3, 1, 4, 2, 5 is not a function because the domain of this is only 1, 2. We require 1, 2, 3 to be the domain. So there is no 3 represented here. That means this is not a function. So we observe one important idea. A relation can become a function only under condition. Therefore, number of relations will be more than the number of functions. So understand all these simple ideas. I do more problems for better understanding. Now we discuss harder problems in the long run. Now we consider an example. F is a function from A to B. This is a notation. F is a function from A to B. A is the domain of the function and B is the codomain of the function. So a function from A to B means A is the domain, B is the codomain. Now you can see an example. A is a set 1, 2, 3, 4. B is a set 4, 5, 6, 7. F is the function. Now F1 is 4. This is the idea. F2 is 5. F3 is 6. F4 is 7. Now here domain of F is A. Range of F is the complete set B, the codomain. Now here is a situation. The function is 1, 1 on 2. One element mapped onto one element. And no more elements from A mapped onto the same element. So it is 1, 1. On 2 means there is nobody else. No one in B without pre-image. You can see another example. A 1, 2, 3, 4. B 4, 5, 6, 7, 8. G is the function. Now 1 goes to 4, 2 goes to 5, 3 goes to 6, 4 goes to 7, and there is nobody who is to correspond to the element 8 in the set B. So range of G is 4, 5, 6, 7. So range of the function is a set of those elements which are mapped by the corresponding elements of A. So range of G is 4, 5, 6, 7 and it is a subset of B. So here range is a subset of codomain. The function is 1, 1, but what we say is into. So the range is a subset of codomain. Subset of codomain means function is into. Range is a subset of the codomain. The function is into. Range equals the codomain. The function is onto. So I understand the difference between onto and into. In the case of into, there may be one or more elements in the B set, the set B, without pre-images. This is a simple idea to be remembered. Here we consider an example. F is the function given by the set of ordered pairs x, y such that y equals 3x plus 1 and x takes values from 1, 2, 3, 4, 5, 6. So the domain immediately comes to you. Now x equals 1, we can put x equals 1, y is 4, x equals 2, y is 7, x equals 3, y is 10, x equals 4, y is 13, x equals 5, y is 16, x equals 6, y is 19. So domain of F is given by the values of x. So it is 1, 2, 3, 4, 5, 6. And range of F are the values of y. They are 4, 7, 10, 13, 16, 19. Or we can write this as F equals 1, 4, 2, 7, 3, 10, 4, 13, 5, 16, 6, 19. Now here the inverse function, this is F. The inverse function F inverse is given by F inverse equals, you interchange the domain and the range. 1, 4 becomes 4, 1, 2, 7 becomes 7, 2 and so on. So F inverse is given here. Now domain of F becomes the range of F inverse and range of F becomes domain of F inverse. 1, 1 function, 1, 1 and onto is a bijection. 1, 1 onto function is a bijection. In that case, there is the inverse. From A to B, there is a function. From B to A also, there is the inverse function. And you can see y equals 3x plus 1 is along a line in the xy plane. If there is a line in the xy plane corresponding to one point of x, you get a value of y. So this is the situation explained here. Now Try to understand the explanations we have given, and we will be doing simple questions for your better understanding. Make sure that you apply all these in your brain and heart and go through the topics, and then convey this message to your friends so that they also will be benefited. Best of luck to all of you. Thank you.